To understand the concept of power, we're going to answer this question, which says an electric generator rated 12 kilowatts, 2 kilovolts distributes power through a cable of resistance 20 ohm. Calculate the power loss in the cable. So first, we're going to write out the parameters here. An electric generator rated 12 kilowatt, that's rating for power. So the power generation of that generator equals to what? 12 kilowatts. And then 2 kilovolt, that's the voltage. The voltage equals to 2 kilovolt. 2 kilovolts. Distribute power through a cable of resistance. Cable of resistance 20 ohms. Calculate the power loss in the cable. So accordingly, when power is being generated, each component in the electrical network takes some chunks or some fractions of that power. Take for instance, if the power is from a DC source, now when it goes to a resistor, the resistor will take its own power, PR. It will take part of that power. If it goes to a transistor, if it goes to a transistor, transistor will also dissipate its own power. So assuming if it was 10 watts that was produced here, at the time it passed through the resistor will take its own. This one, transistor will take its own. Every component, if you have a light bulb there, light bulb will also take its own. So that's how it is. Even the cable or wire in which the current or the power is being transmitted through will also take part of its power. So if you're generating 10 watts, by the time it reach to wherever it reach, the power would have been shared accordingly. So same thing goes to even high voltage engineering. So the basic calculation now, we have to find the power loss in the cable. That we have to find the amount of power the cable dissipates, takes on its own. So this is the power generated, this of 12 kilowatts. And this is the voltage of the generation. And then we know that the formula for power is what? Current times voltage. So now we are going to use this first parameter and this second one to determine the current from the generator. And that's if you make I the subject. I equals to what? E divided by V. So our P here is 12 kilowatts. And then our V is 2 kilovolts. Kilo will cancel kilo. 12 divided by 2 is 6. So the current is 6 amps. So the current coming from that generator is what? 6 amps. So the current that will be running through the cable is what? 6 amps. So therefore, to get the power dissipated by the cable, and you know power is what? I times V. We are not talking about voltage of the cable. If you remember that Ohm's law, that V equals to what? IR. So if you substitute IR in place of V, you have what? I squared R. So this is the formula we are going to use to evaluate the power dissipation in the cable. Now, having found the current, I squared will be 6 times 6 times what? 20. 6 times 6 is 36 times 20. 36 times 2 is 72. So that will be 720 watts. So the power dissipation in the cable, or the power loss to the cable, is what? 720 watts. So what will be the power that will be received at the end of the cable, assuming that there is another device at the end of the cable? That will be the total power generation minus the power loss from the cable. Will give you what the other end of the cable is receiving. So the answer to this question is C. Thank you. Join our WhatsApp group to book for online classes in real time and also get practice questions. The link is in the description. Thank you.